continue on the air-fuel ratio. Before that, ada soalan from previous. Faham? Okay. Just to recap, yesterday kita cari A. The important part is to find the A. Then from there, we generate the combustion equation. Okay, today, we will go through for the air-fuel ratio, where this is a standard measure of the amount of air used in actual combustion system. Definition of stoic air fuel means the minimum fuel that required for the combustion. Okay, this is the formula. AF stoic at stoic equivalence to M air over M fuel. Okay, where the M air, M is mass. Can use this equation to find the M air. A here, the one that we calculate from the combustion equation. So, equation. Okay, 4.67 is constant, standard. Now, M fuel, how to find M fuel using the molecular weight of fuel. Okay, now this one, M fuel, bila kita guna gas. Later on, when you use solid, it will be different. Okay. Okay. Sorry. Okay, next is equivalence ratio. Just now AF ratio, air fuel ratio. Now equivalence ratio, by the sign of this, is commonly used to indicate quantitatively whether a fuel oxidizer mixture is rich, lean, or at stoic. Meaning that from the ratio, the AF stoic and AF actual. This one is the minimum that we calculate at stoic and at actual. Okay, so dia akan ada satu value where this value, if it is more than 1, it shows the combustion is fuel rich or less air. Incomplete combustion. If less than 1, it is fuel lean, excess air. So you have excess of air. If equivalence ratio equals to 1, it is at stoic. Just at minimum air. Okay. Notice the term. Sometimes use the term fuel rich. Sometimes using the term less air. Okay. Now this one to calculate the percent stoic air. So it involves the equivalence ratio just now. Stoic air, 100% divided by the equivalence ratio. Then you will find your stoic air. Percent excess air from this equation. Okay, so you need the equivalence ratio value. If it is not given, you can find from the AF stoic over AF actual. Okay. Now we go to the example. Consider the stoic air-fuel ratio in combustion of methane in atmospheric air. Okay, methane. So the fuel here is methane. This is the combustion chamber. Then we have fuel and air. Are you familiar with the process flow diagram? Biasa kalau I akan letak this one in and out. Okay, usually this one is we call as process flow. So this one in fuel and air. Combustion chamber. So we have the product. Complete combustion. Okay, from this process flow, we need to generate the combustion equation. Okay, where this is the general combustion equation. Yesterday we had calculated the A and okay, so this as calculated yesterday. Kita dah try semalam kan? Using methane, where the A equals to 2. Okay, kau nak try balik buat equation? Proceed kan? Okay. Then from there, we need to find the air-fuel ratio. We know that the air-fuel ratio ini dia punya equation, air-fuel ratio, where we need the A. Okay, A ni important. Okay, then from there, substitute all the infos. A, kita dapat 2. So MW air is 29 over molecular weight of the fuel. So C is 12. This is for C. This is for H. Why 4? Sebab H ada 4. Kan? So 1C dia macam 1 darab dia punya molecular weight plus 4 untuk hydrogen. So you will get 16 down here. Okay, so from there you dapat this is the AF for the combustion process.
And then applying electrolysis.
Yes. Air ini memang common numbers lah, kita akan guna 29. Fix 29. Yang 2 ni yang A tadi. Okay. Okay, so the amount over here, meaning for every 1 kg fuel, you need this amount of kg air. Daripada equation, 1 mole fuel needs 2 mole air. So in kg, this is the amount, the minimum amount. If you supply 17 kg air, what happen? If supply 17 only, incomplete, less air, not enough air. If you supply 18, excess air. Okay, so that means for the design of your compressor to supply the air, so must meet this minimum. Usually kalau design, you will have a plus minus. Okay. Okay. Now example 2. This one, the fuel is N-butane. C4H10. Make it larger. Okay, with two conditions. Theoretical air and 50% excess air. Theoretical air means at the minimum. 50% excess air, you have excess of air. Okay, so this is the process flow. Butane and air enter the combustion chamber, and these are the products. Okay, you can see over here, you have O and 2. This occurs when you have excess air. Kalau you just theoretical, only this part. Okay. Now, theoretical air means you have this one, CO2, H2O, and N2. Sorry, include with the N2 for the theoretical. Okay, so you need to find the A, B, and C. Tapi to calculate the air-fuel ratio, the important part is the A. Okay, but usually it is better for you to generate the combustion equation so that you can see the whole picture. Okay, dalam notes you mungkin guna letter, different letter, kan? So saya dah tukar kat sini, A, B, C, so that you tak confused. Whatever letter that they use in front here, still use the same equation, which is the X plus Y over 4. Okay, B is X. C is Y over 2 untuk H2O. Okay. Yeah. Balance equation, yes. Okay, yang ni 3.7A, 3.76 multiplied by the A. Okay, from there you dapat the B4C equals to 5. A, this one 6.5. Complete combustion ada. Sebab nitrogen tu inert. Dia tak terbakar. Dia tak contribute to the combustion actually. Dia inert. Okay. Okay, the term just now inert, the N2. Ini common if the gas is not contributing to the process. Dia just macam dalam air dia memang ada kan. Tapi dia tak contribute pun. So we call that as inert gas. Okay, then okay, kita dah dapat A. Then from the A kita boleh calculate the AF for theoretical. Okay, so from there, ini molecular weight of the fuel. 4 sebab ada 4 carbon. Then 10 of hydrogen. C12 H1. Okay, so ini theoretical dia. Theoretical AF. Kan? Okay, now we move for the 50% excess air. Okay, theoretical here means dekat depan ni adalah 1. Means 100% air. Kat sini 1. Tapi kita tak tulis sebab dia 1. Kalau 50% excess air, if excess means 150 of the theoretical air. Okay, so that's why daripada combustion equation, the previous one, we include 1.5 in front of the A, multiply. Okay, and dalam product, you can see over here, excess air means dekat oxygen multiply by 0.5, and also the nitrogen multiply by 1.5. Kenapa oxygen 0.5, nitrogen 1.5?
Kalau excess ada 50, ada 50% yang
O2. N2, kenapa dia 1.5? Dia tak contribute. Yes. Apa yang masuk, dia akan keluar. Banyak mana masuk, banyak tu keluar as N2 lah. Okay. Okay, so daripada excess air punya equation, once you dah simplified, this is your A. The total A. So A ni yang akan guna untuk calculate excess air AF. Okay. Then you akan dapat different value of the fuel. Okay, so compare kalau tadi is 15.5 theoretical, the minimum amount. Then you have 50% excess air, 23 kg per air. Okay, you can imagine the different design of compressor to supply this value of air. Okay. So that's why in for the excess air, we cannot simply put, let's say 70% excess air. We cannot simply put. You must calculate berapa banyak yang optimum for excess air. Kalau you simply letak 70%, then amount of air kat bawah tu will be very big. Then design compressor different, design all the piping also different. Okay.
Theoretical air.
Usually theoretical air 100%. Kalau 200 then already excess. Excess of 100%. So kalau dia kata 200 theoretical air, macam dia cakap kan, this one 200 means that dia ada 100% excess air. Then it will be a waste lah. Okay. Okay, now we proceed to example 3. A small low emission stationary gas turbine engine operates at full load at an equivalence ratio of 0.286. Okay, this is the equivalence ratio with an air flow rate of this. Air flow rate. Okay, this is air flow rate. So the equivalent composition of fuel, natural gas, is this. This is the fuel. Determine the fuel mass flow rate and the operating air fuel for the engine. So this one dia nak mass flow rate, m dot. Ini air flow rate, m air. Dia nak m fuel and also the AF actual. How we know AF actual? Because the other mentioned operating. Dia bukan extract. Okay. Operating tu, the term operating. Okay, the term operating means the actual operating condition. So the AF kat sini adalah AF actual. Kan kita ada AF start. AF start means at the minimum. Okay, now dia bagi equivalence ratio 0.2, which is less than 1. Less than 1 tadi from the slide, earlier slide, ini. Fuel lean. Excess air. So dia ada excess air. How many percent excess air kita tak tahu. Dia just bagi equivalence ratio je. Okay. Okay, then dia punya fuel is this one. So meaning that fuel of this with excess air. So your product akan ada CO2, H2O, O2, N2. Fuel and then you ada air lah. Okay, how to find the M fuel and AF? We know that from the equivalence ratio, equation dia adalah AF start over AF actual. Kan? So from here kita boleh dapat AF actual. Now to get the M fuel, we know that AF adalah M air over M fuel. So ini dalam rate, both will be in rate lah. So kita kena cari the AF actual first untuk kita dapatkan M fuel over here. M air tadi dah given, which is 15.9. Kan? Okay. So now, kita nak dapatkan AF actual. Equivalence ratio kita ada we need to find out AF stoic. How to get AF stoic? At stoic. So kita generate the combustion equation, or in short, we just need the A value kan. So the A from the fuel, kita dah boleh dapat A from the fuel. X plus 4.32 over 4. Kita boleh dapat A. Two point two four, yes, correct. 2.24. Then masukkan dalam AF stoic. AF stoic. Ini A tadi, so ini molecular weight. Kalau you guna 29, then might be a bit different. Kalau you guna 29, akan dapat 16.95.
There will be no fuel. Focus. Secret.
Yang mana? 12. 18 ni adalah ni. Molecular weight of fuel. 1.16. C kan? 1H. Ni roughly you akan dapat 18.24 lah. Okay, yang AF start. Okay, once dah dapat AF start, sekarang kita nak cari AF actual. Bahagi dengan equivalence ratio. Dapat. Okay, so once kita dapat AF actual, kita boleh cari M fuel. The AF actual we know is M air over MF. So kita nak cari MF. Okay, ya. So all the equations tu dia interconnected lah. From the equivalence ratio, AF. The A is the important part.
Investigation yang awal. If we think this situation.
Depends pada question. Dia nak add start ke add access. Tapi kalau dalam case ni, dia operating. So by right, A actual lah. You boleh generate the actual combustion equation. Tapi dalam equation ni, AF, kita just perlukan the A. A yang kat depan tu. A ni adalah A start. AS. Ini A start. A stock. Sebab tadi kita nak cari AF stock kan. Untuk kita nak dapatkan AF actual. So once kita dah dapat A stock, kita boleh calculate AF stock. Okay. From AF stock, kita boleh dapat AF actual. Okay. So from this AF actual, actually you boleh juga cari A actual. Dia boleh dapat A actual. Tapi sekarang A actual kita tak perlukan. Kita tak perlu tahulah sebab kita just nak proceed untuk cari M few. Dia faham tak? Ni.
Boleh jadi input actual.
Sama. Ini AF formula. Dia boleh jadi untuk stock and actual. Sama. The difference is A ni. Sama ada you guna A actual atau A stock. Betul. Kalau A stock, kita straight away boleh cari daripada fuel tadi. Kan? Ni AF stock, so sini A stock lah. Kalau AF actual, A actual. So kalau A actual, let's say yang 50% tadi tu, excess air. A actual dia adalah, A actual. Let's say A stock tadi. A stock multiply by the 1.5. Dia tak bagi tahu, tapi from the equivalence ratio kita tahu dia ada excess air. Question ni dia tak minta untuk cari how many percent of excess air. Unless kalau dia minta untuk cari excess air, you boleh guna equation excess air tadi. This one. Okay, so let's say dia nak excess air kan. Tadi 0.286. So for example yang tadi. 1 minus 0.286 over, 286 over 0.286. So from here, you boleh tahu berapa excess air. Cuba try calculate. Two? 2.5. Besar kan? 249. 249% tau. Ni dalam persen. So the excess is too big lah. Excess of air. Ini excess air, not theoretical. Kan? Kalau katakan you cari yang ni kan, stored air. Okay, cuba tengok berapa dapat. $349. Okay, ini dapat 349.7 lah. 349. Okay, ini stock maksudnya ini minus 100. Stock kan theoretical 100 kan? 100% kan? So bila minus 100, you akan dapat 249 balik. Ni excess of 249. Quite big lah. Okay, boleh. Dia depends pada question. This question dia tak minta untuk cari A actual atau dia tak minta generate the actual combustion equation. if dia minta to generate the combustion equation, kita kena cari A actual, then you need to generate the equation. Okay. You need some time to digest? Lepas okay. Okay, now kita try final exam January 2018. Let me make it bigger. In 2018, it asks you to determine the stoic air fuel ratio for the following types of fuel. Okay, AF, so we just need the A. So stoic just cari daripada fuel given, the AS. So for number 1, butane, the A would be 4 plus 10/4. (6.5). Okay, then substitute in the AF ratio calculation, then you'll get the AF. Yes, correct. Make sure you tulis juga unit dia. So this system need that amount of air for 1 kg of fuel. Then try proceed for number 2, where it has oxygen. Molecular weight for oxygen is 16. Yes, correct. Okay. Okay. Ini kalau fuel dia single fuel. So number 3 is a mixture of butane and propanol, where the mole fraction of propanol is 0.78. Propanol 0.78. Propanol. So butane berapa? Ah, 0.22 butane. So the mixture. Okay. Untuk nak generate the A, we need the C. Ni kan? Tapi since this is a mixture, so kita kena generate this from the mixture. Okay, so kita kena cari satu-satu. So C, dia ada 0.78 from the propane. Okay, propanol tadi ini dia punya equation kan? Okay, ini dia punya equation. So dia ada 3 carbon. Plus 0.22 daripada butane, dia ada 4 carbon. Okay, so kita akan dapat total C kat sini. Same goes for the H. Yes, dia dapat yang sama tak? C, H and O. O since dia ada dekat propanol saja. So multiply by 0.78 only lah. So the new fuel chemical formula C 3.22, H 8.44, O 0.78. Okay, so dari sini cari dia punya A. New A untuk the mixture. AF. Berapa? AF around there. A dia betul. 4.94. Okay. Betul lah. So using the A, cari the new AF. Berapa tadi dapat? 11. Should be around there. Okay, take your time to digest first. Okay, we proceed. Okay, now for the exam 2019, I ask you to consider a natural gas fuel with the following composition: 94% mole of methane, 4 mole% propane, and 2 mole isobutane. Okay, isobutane ni is C4H10. Methane CH4. Propane C3H8. Okay, saya akan bagi chemical formula lah kalau dalam midterm ke final kan. Sebab you tak familiar. Kalau student chemical, I tak bagi. They should know already. Okay, so the question asks you to write up the complete stoichiometry for this fuel burning with air. Stoichiometry. So we know that dia punya process flow is the mixture of the fuel. We have methane plus propane and plus isobutane. Ini dia punya fuel plus the air. Okay, so you have CO2, H2O, N2. Okay, now it asks you to write the complete combustion. So kita kena cari dia punya fuel dulu. Sebab fuel tu is a mixture. So similar as previous, kena cari C and H from the mixture. So buat satu-satu untuk carbon, 94% of methane. So methane carbon 1. Then 4 mole, 0.04. Propane 3 carbon. Then plus isobutane is 2%. Divided by 4. Apa dapat? The new formula. Yes, correct. Okay, so this is the new formula. So generate the stoichiometric combustion equation using the new formula. Kita kena cari A dia. So from the new formula, find the A. Two point two one, yes. 2.21. Okay, so masukkan dekat equation. Then H2O berapa? Yes, correct. 2.14 H2O. 3.76 plus multiplied by the A for N2. So you can dapat 8.3 lah. Betul? Okay. So ini jawapan untuk A. The final answer. But in order to get to this answer, you can first step is to find the new mixture, chemical formula, then find the A. Then only you can generate the final equation. Okay. Okay. Then we proceed to B. It asks you to determine the stoic air-fuel ratio, where we already have the AS just now. 2.21. Just include in the equation. The 16.99 kg air over kg fuel. Okay, just to share with you macam mana the marks is being distributed. Okay, so the new C and H brings 1 mark each. Then the new chemical formula, 1 mark each. Then the combustion equation, 2 marks. 2 marks here adalah 1 from the input side, the feed. 1 markah dekat product side. Nampak tak? Ha? Ni yang mana? Oh, sorry. Stoic. Sekejap Yang tu access. Yang C, sorry. Tu yang C. Sorry. Okay. Oh, yang ni 1 je. 1 markah. Sebab A dapat 1 markah. So, this one, combustion equation 1 markah. Biasa saya akan bagi input side half marks, output side half marks. So, kalau you salah somewhere else, still dapat markah. And the air-fuel ratio is tadi 4 marks. So 4 marks dekat equation dapat markah juga. So if you have no idea how to answer, just write the equation. Then all the inputs, substitute all the values, dapat 1 markah. Then the final one, 2 marks. 2 marks here inclusive the unit. Okay. Now, next, C, it asks to calculate the composition of the combustion product gases. So, we move to the next slide. Okay, C asks you to calculate the composition of the combustion product gases if the fuel is fed to combustion chamber with equivalence ratio of 0.8. Okay, composition ni is product gases. I think this one we KIV first, but this one in next chapter. Okay, we KIV first this question. Once we finish that topic, we come back to this. Okay, I proceed a bit more. Yang tadi previously the fuel that we use is only gas. Now if you have solid fuel, basically it is just similar. It's just that in fuel sometimes you have the N. Okay, N dekat sini akan contribute to the combustion, not like N2 kat sini. Okay, so basically it's just similar, but for the N over here, the N2, since fuel ada N, so that akan contribute dekat output, how many N produced. O here is not the oxygen, O here is this value. Okay, so the A similar, like macam sebelum ni juga. Instead here they use another letter. Okay, here X is 1. They are fixed to 1. Do you know why? Okay. Why kita letak 1? Remember yang kita calculate the chemical formula? Kita normalize with respect to C. So C must be 1. So in solid, anyhow, C is 1. Okay. Now, this one, I have only 3 more slide. Kita proceed. Okay. Now, ini nak cari calculation, theoretical air flow calculation for solid fuel. Okay. So usually kalau solid fuel, the question will give you this proximate and ultimate analysis. Where previously kita dah try to generate the chemical formula from the ultimate analysis. Okay, still remember the step. Cari mole, to normalize there. Okay, cari weight, first basis, then cari weight, then cari mole, then normalize. Okay. Now, once you get the chemical formula from here, to generate the combustion equation. Similar as the previous when you use gas. Still kita ada A. Okay. Then this one, N here, it depends to this one. Okay, so sekarang A dia, because we have N as well, so ini dia punya A. Okay, now this is the general combustion equation for this fuel. Okay, up to there, can ah? Now the question asks you to find the air fuel ratio. So kita dah dapat A tadi. A kat sini. Now what I want to highlight is M air sama 4.76 multiplied by A, then multiplied by molecular weight of air. Now for the fuel, 100 gram of solid fuel divided by the mole of carbon. Okay, 4.1, where comes 4.1? Daripada sini tadi. Okay, so it depends berapa mole carbon yang you calculate. It depends. This is not fixed. Okay, so 100 gram ni pun based on your basis tadi. Basis. Okay, sebab kita assume solid fuel is 100 gram. So daripada that 100 gram, kita ada 4 mole carbon. Okay. Now, 100 gram bahagi 4.1 mole, then kita dapat M fuel. Sebab apa kita just guna carbon, kita tak include the rest, because the same reason, carbon is the biggest component in the fuel. That's why kita based on carbon. So this value, M fuel ni just an approximation lah. Okay, so that's the difference between gas and solid fuel. So the formula still the same. It's just that the M fuel over here. So sini dapat dia punya AF. Okay. Sebab that one is the major constituent dalam solid fuel. Yes, we can also include the rest. Kalau all to known lah, known value. Boleh juga kalau you nak buat ini sebab dia based on 100 gram solid fuel kan. Where dekat sini tadi you dah cari. Semua ada mole dia. Kan? So boleh juga include. No issue. Answer akan jadi lain. So kalau I tengok your answer not same as mine, I akan tengok dekat sini you bahagi dengan apa. Okay. Okay, I'm not that strict lah. Still flexible because it depends on how the method that you use. Kan biasa engineer kita ada banyak method. Not fixed to only one. Okay, this one sempat tak nak buat? Ada 10 minutes je lagi. I think this one we save for the next lecture. Boleh? But there ada few steps involved. Okay, so 24, 25 we save for the next lecture. Nanti kalau rushing nanti tak faham. Okay, so that's all for today's class. You can try dalam lecture you ada tak? Dalam slide you, this one ada. Ada kan? This one, last one. Ada. You can try first. Okay, so that's all. Thank you. Later I will upload this week punya lecture notes recording lah.